Now we are going to start with the last property of the colloids, that is the coagulation, or you can say the precipitation. It is an important property. Now the one thing is that what is coagulation, or like what is the reason behind that the colloids gets coagulated. The reason is that, as you already know, that we have two types of colloids depending upon their interaction with the interaction between the dispersed phase and the dispersion medium. We have two kinds of colloids. One is lyophobic and one is lyophilic. Right. So we have two types of colloids depending upon their interaction. One is the lyophobic, other is the lyophilic. So as you already know that in lyophilic, the dispersed phase particles have love for their dispersion medium. And in contrast, when we talk about lyophobia, dispersed phase actually hate the dispersion medium. They have the hate factor. They have the hate factor and they have the, I'll draw a heart here, they have a love factor. So that means if we compare their stability, so what happens, the lyophilic ones are stable as they have love for each other, but they are not stable. But in circumstances, like in certain circumstances, we know that like under special conditions we make this lyophobic colloids by using the special methods. We already did that. We can actually use the special techniques to mix the dispersed phase and the dispersion medium. But what happens in the lyophobic, the dispersed phase and dispersion medium is like it is a colloidal solution, but it is not too stable as we compare it with the lyophilic. So what happens in this case, by using certain factors, what we can do, as we all know that whether it is lyophilic or lyophobic, they are charged, they carry a charge, you know that all the colloids carry a charge, and the reason behind that they have charge is an electrolyte or any impurity which is present. We know that. So what happens, like if you you can say apply certain methods in which you can just remove the charge, then what is going to happen, they are going to get uncharged, and when they are going to get uncharged, what they are going to do, that they will just, like suppose this is my colloidal particle, this is my colloidal, but I have used certain techniques, now it is uncharged and this is also uncharged. So what will happen, they will just approach each other, they will unite with each other and form a one, you can say a bigger molecule, and this bigger molecule will settle at the bottom. That means we'll get to see that these particles actually coagulate. That means the particles of 1 nanometer and 100 nanometer range particle, they will just when they will become uncharged, they will start coming to approaching each other, and when they will approach each other, they will get fused into each other, and as a result they will form a particle which will be a bigger in size, and likewise it will settle at the bottom. This is something called as coagulation or a precipitation. Now we will be seeing that how we can precipitate the lyophobic colloids, like how we can separate these particles or how we can make these particles settle at the bottom. So what methods we can use actually. So the one is electrophoresis, the other is addition of opposite soles, third is persistent dialysis, next is boiling, and last but not the least is addition of an electrolyte. So see that how we are going to use these methods. The basic thing is that when we are applying certain kind of method, what we need to do, we need to uncharge the colloidal particles, because the moment they will become uncharged, they will start approaching each other, they will fuse with each other, and in return they will form a bigger particle that is going to settle at the bottom. So this is what we are going to see. So we are just going to study the techniques that how we can make the colloidal particle uncharged. So the first is electrophoresis. So what we are going to do here, we have taken this apparatus. This is a platinum electrode, a battery of high voltage obviously, and we have a colloidal sole here. So what happens when we switch on the current? So what happens, these particles, like we know that there are certain colloidal particle with positive charge, we have certain colloidal particle with negative charge, we have these kind of things according to the electrolyte which is present. So what happens when we switch on the current? So as this is a negative electrode and this is a positive electrode, so that means these positively charged colloidal particles will move here, right? So when they will move here, their charge will get neutralized and particle will start depositing here. And likewise, the negative one will go towards the positive pole, they will neutralize their charge and they will start depositing here. So what happens when they get deposited here? They just come in contact with each other, and when they come in contact with each other, they form a bigger particle, which you can say they just gets coagulated. And if these kind of particles are present in dispersion medium, they are obviously going to settle down. So this is what we have as electrophoresis, that is by passing an electric current, what happens, the colloidal particles, as they carry different charge depending upon the electrolyte, so they are going to move towards the opposite poles, and there their charge is going to be neutralized, and likewise the colloidal particle will become uncharged now, and it will start depositing on the platinum electrode. And when it is depositing on the platinum electrode, they are going to fuse, they are going to form a bigger particle that will settle at the bottom. So this is what is the electrophoresis. Second is addition of opposite soles. Suppose I have one colloidal particle, this is my one colloidal particle, which you can see is positive charge. As you can see, there are a lot of positive charge which is adsorbed on the surface. Now I am going to add another sole which will carry a negative charge. Obviously it carry a charge, but a charge opposite to that. Suppose it is a positive one, so here I am adding a colloidal particle with a negative charge. Suppose I have a negative one, so I am going to add a colloidal particle with a positive charge. So what in turn they are going to do? So when we will add them, this charge somehow will interact with each other as they are opposite ones. They are going to neutralize. So what is going to happen? They will lose their charge. Their charge will get neutralized, and when it will get neutralized, obviously these colloidal particles will approach each other. They will form a one particle, an uncharged particle, which is going to settle at the bottom. So this is again a coagulation done with the help of adding a new other sole into the solution. And what is the criteria of the selection of that sole? Obviously the criteria behind that the sole should have an opposite charge, if it is positive, so we are going to select a particle with a negative charge, and if it is negative, we are going to select a colloidal particle which has a positive charge on the adsorbed surface, because what we need is, we need to neutralize the charge. So this is what is done when we add an opposite source. Third is the persistent dialysis. Dialysis, you know that like what we do in the dialysis, there is a membrane. We already did it when we were preparing colloids, that there should be a membrane which allow the selected particles to pass through, right? So what same is going to happen here, but we need a persistent dialysis. That means we need to carry out dialysis for a longer period of time, because we need to uncharge the particles, and for uncharging the particles we need to separate all particles of electrolyte and impurities, so that the sole which is left behind should be uncharged, because at the time they will lose the charge, they will start coming towards each other, and when they will approach each other, they will just get fused into each other, and likewise we will have the coagulation. This is what we are looking for, right? So see what we have here now. We have, this is a membrane, you all know, this is a membrane which is permeable to the smaller particles but not to the bigger particles. So here I have applied an electric field to just speed up the reaction, and persistent, that means we need to do this dialysis for a longer period of time. So what is going to happen here, we have a right. So what is going to happen, like when we will apply an electric field, when a current is switched on, obviously it is going to have an electrolyte. Let us say the electrolyte it possesses is NaCl, and although it has some neutral impurities, this I am showing with green. So what happens, when you switch on the current, these negatively charged particles start moving towards the positive pole, and these positive ones start moving towards the negative. And this membrane is allowing the selective particles to pass through. That means it is allowing the electrolyte and the impurities to pass through, but not definitely the colloidal particles, because they are bigger in size. So, and the neutral impurities, they will just diffuse as such, they will settle at the bottom. So what you are going to have here, obviously when you do this process for a prolonged period of time, you are going to get the colloidal particles. You are going to get the colloidal particles which are uncharged now. They don't have any charge. So obviously they will start moving towards each other, and they will just fuse to form a bigger particle that will settle at the bottom. That means we will see a coagulation occurring in here, and the reason behind that is the persistent dialysis. Next is the boiling. So what do we do in boiling? This is what we have, a colloidal particle, you know that it has a charge adsorbed on the surface. So here also I have a colloidal particle in which the charge which is adsorbed is positive one. You can do it with the negative one also, because it hardly matters that what kind of charge it possesses. What matter is that we need to uncharge the colloidal particle. So whether it is with positive charge or whether it is with negative charge, we need to remove that charge, right? So what we do here, we just boil it. We just boil the colloidal solution. So what happens when we boil them, these particles which are adsorbed on the surface, they you can say they gain the energy, their kinetic energy increase, that means they speed up and they start moving away. And we know that when they will move away, we will be left with the colloidal particle which is uncharged. So obviously those uncharged particles start approaching each other, then just getting fused into each other. This is what is the coagulation. And when they will get coagulate, they will form a bigger particle and that will settle at the bottom. So this is what we have done, coagulation with the help of boiling. The reason is that we need to uncharge a particle. Here we uncharge the particle by using an oppositely charged electrode. Here we uncharge the particle by using an oppositely charged sol, so that the neutralization of charge can take place. Here we did it by separating the all charged particles by applying an electric field, and here we are just separating it by heating. So this is what we can do. The other method, we can do it by adding electrolyte. Suppose this is my colloidal particle and it has a positive charge on the surface. As I told you that it can have a positive charge, and likewise if an electrolyte is negative, so it may have the negative charge. So that means when the electrolyte is in excess or when the electrolyte is present in less amount, the particles are going to be uncharged. So this is what we are going to do here. So what I am going to do, I am going to add an electrolyte. Right, I am going to add another electrolyte, suppose, or you can say we are going to add an ion, let's say phosphate ion. So what it is going to do? So obviously it will have a negative charge. So this negative charge is going to interact with the positive charge. And we know that like we have added certain electrolyte or we have added a certain coagulating ion. This will be a correct term, coagulating ion. So that means when we are adding a coagulating ion, and obviously the coagulating ion which we will be added will definitely possess the opposite charge to which the charge is possessed by the colloidal particle. So here, as I have made that it carries a positive charge, so obviously I am going to add a coagulate ion which carries an opposite charge, that means the negative charge. That is why I told you that I added a phosphate ions. So these negative ions is going to interact with the positive ion, and what they are going to do, they are just going to neutralize the effect. So there will be no charge left. So that means the colloidal particle will now become uncharged, and we know that the moment they become uncharged, they keep on, you can say, they start coming towards each other because they don't have affinity for the dispersion medium. And when they just approach each other, they fuse into each other and form a bigger particle that settles at a bottom. So that means by any of these methods, we can just coagulate the ion. The one more important thing, the mechanism that is in which we are uncharging the colloidal particle by adding an electrolyte, it obeys an Hardy-Schulze rule. It obeys an Hardy-Schulze rule. What's that? It's that more is the magnitude of the charge, more is the magnitude of the charge of an electrolyte which we are going to add. Or you can say more is the charge of the coagulating ion, more the ion will possess the power of coagulating. That means there should be a balance between the coagulating ion and the ion which is present on it. Or you can say more is the charge on the coagulating ion, more coagulation power it is going to possess, right. So this is what is the adding of electrolyte, and this is what is the Hardy-Schulze rule. So by any of the methods, we can just you can say we can just separate the dispersed phase of lyophobic from the dispersion medium. Now the reason is that do we have any method to coagulate lyophilic sols? As we all know that the lyophilic sols, they have affinity for each other, they actually love their dispersion medium. You know that, I have already written here, they have love for their dispersion medium and they are actually stable. So if we need to coagulate lyophilic, so what do you think, that can we coagulate lyophilic or not? Obviously we can do that, because we know that the reason behind the stability of lyophilic is the two. One is their love for dispersion medium, or we can say due to solvation. That means the dispersed phase gets dissolved in the dispersion medium. And second is the charge. Second is the charge which is possessed on it. So that means if we are successful in removing these two factors, that means we can just coagulate the lyophilic sols also. So now the question is that how we can just remove these two factors. So we can do it. Suppose I'll make a lyophilic sole here. This is my dispersion medium and this is my dispersed phase. This is my dispersed phase. So what I'm going to do here, I'm going to add a suitable electrolyte because I need to remove these two factors. So I'm adding a suitable electrolyte. Now what is the criteria behind selecting a suitable electrolyte, or which electrolyte here is suitable for us? So the reason is that like the choice is made merely on the basis that we need an electrolyte which will just disturb the solvation. That means, as we know that here the dispersion medium and phase, they have interaction for each other, right? But now when we are adding this electrolyte, so this electrolyte may have a love for the dispersion medium or may not have the love for the dispersion medium. So what is going to happen when we are going to add this electrolyte, it is just going to disturb the balance or disturb the affinity between the dispersed phase and the dispersion medium. That means on adding this, their love for each other is going to get you can say affected. That means they will not further love each other. So that means it is going to disturb this solvation. It is going to disturb this solvation. Now secondly, what we are going to do, we are going to add another substance to it which is going to remove the charge. Which is going to remove, as I told you, like if I say that it possesses a positive charge, so I can add a substance which carries a negative charge. So that means here what they can do, they can just neutralize the charge. So likewise, I am adding some substance other to this, and what that substance is doing, it is just neutralizing the dispersed particles. That means it is just making those particles uncharged. And the moment we just lose these two factors, that means the lyophilic particles will also approach each other, they will fuse with each other, they will form a bigger particle, and at the end of the story what we are going to see that they also get coagulated. They also get settles at the bottom. So that means coagulation can occur in lyophobic as well as in lyophilic soles, and the reason is that like what we have to do actually, we just have to make it unstable. And how we can make it unstable? By just removing the charge from each other for the lyophobic, but in the lyophilic we need to consider the second factor also. That means we need to remove the solvation, we need to reduce the solvation also, because we need to put a hate feeling between the dispersed phase and dispersion medium. And how we can do that? We can do that by adding a suitable substance. That suitable substance will just disturb the solvation power of that dispersed phase into dispersion medium, and the moment we succeed in this case, we will just see that this lyophilic soles also get a hatred feeling between them, or they can also coagulate and they settle at the bottom. So this is what is the coagulation property. So all those properties we have discussed till now are very important. I think you remember we did colligative property, we did electrophoresis, we did Brownian movement, we did charge, we did the color, they possess the color also, we did that they have a special property, that is the Tyndall effect, and the last property, that is the coagulation. So these all properties are very important. Tyndall effect, Brownian movement, coagulating power, these three properties form a basis of these colloidal particles. So you need to remember them, they are very important one. So now we are just reached at the end of the chapter, and we will be starting with the last topic. Here we will be discussing a certain factor, that is the emulsifying agents and all. This is what we are left with. So just try to practice that how we can make the colloids, how we can purify the colloids, and what are the special properties of the colloids, right?